So today's lesson is on drawing scale diagrams. So what we can do is we can draw enlargements or reductions of objects. Okay, so let's look at an example. Terrell is a builder. He wants to construct a patio for the elementary school. The patio is 12 meters long and 9 meters wide. If a scale of 1 to 300 is used, what are the dimensions of the drawing? And then part B, draw the scale diagram. So if a scale of 1 to 300 is used, here's what that means. It means we're going to take these dimensions, we're going to divide them by 300 because the actual drawing is going to be 300 times smaller. But to make this be something that is useful to us, we're going to have to take those measurements in meters and turn them into what? Centimeters. So how many centimeters are in a meter? 100. So if there's 100 centimeters in a meter, that means that 12 meters is 1,200 centimeters. And we get that by multiplying 12 by 100. And if we multiply 9 by 100, we get 900 centimeters. Now it says a scale of 1 to 300 is used. So what that means is we have our length, and our length is 1,200 centimeters, but we're dividing it by 300. What is 1,200 divided by 300? 4. It's 4 centimeters. And the width, we're going to take 900 centimeters and divide it by 300. What's 900 divided by 300? 3. So we get 3 centimeters. So now with our rulers, we are going to draw, essentially we're going to draw a rectangle. And our rectangle we're going to make sure it's 4 centimeters long and 3 centimeters wide. So my rectangle will look a lot different than yours because of my ability to zoom in and whatnot. It's not going to look the exact same, not by a long shot, but at least according to my ruler here, that's 4 centimeters long. That's 3 centimeters wide. And like I said, now when you draw a scale diagram, it's usually standard procedure to go ahead and draw in the original, like the actual dimensions of the object, which is 12 meters by 9 meters. And yeah, that's about it. Okay. So draw in your scale diagram and do your best to make sure it's straight and it looks like a rectangle. All right, the next question. Shaylin works for VA Plumbing and Electrical. She looks at a diagram for a steel washer. Draw a 2-to-1 scale diagram for the top, side, and front views of the washer. Okay, so let's talk about what this is going to look like. Here it is. So if we're looking at this and we're looking at this from the front, then what we're going to be seeing is like the ring size washer. That's if we look at it from the front. But if we look at it from the top or from the side, it's actually going to look like a rectangle of sorts. So we'll do the top and the side. Yes, we'll do the top and the side first because they'll be a lot easier to draw. Now this is actually an enlargement, which is important. It's a 2-to-1 enlargement, which means we're multiplying all the dimensions by 2. Okay, so if we think about this, we have to zero in on the width of the washer. It's 1/16 of an inch. So if you double that, you're just multiplying it by 2, and that's 2/16 of an inch. So that's important. And as far as how long it is, or really, if you think about it, it's actually the diameter of the outer circle. It's 3/4 of an inch, but we're multiplying that by 2. And if you multiply 3/4 by 2, then you get 3/4 times 2/1, which gives you 6/4, or 1.5 inches. So it's going to be 1.5 inches. 3/4 times 2 is 1.5. Okay. And this is why we have our rulers. But when we use our rulers, we're going to have to be using the imperial side of them to help us out. Now, the thickness is 2/16. So if I draw something that's 2/16, it's not going to be very big. It's just going to be the distance of 2 ticks on your ruler, and it's going to be 1.5 inches long. So it's going to be that long for me. And there we go. And I'll just close it off. And so from the top view, that's what it's going to look like. And it's actually going to look the exact same from the side view. Side view and the top view are going to be identical. So I'm actually going to cheat and just copy this one over here for the side view. So when you're done with the top view, make an exact duplicate of that, and that's what the side view is going to be like. If you view this from the top or you view this from the side, it's going to look the exact same. When you get to the circular parts, you have to take a look at the inner circle here. This inner circle, as pixelated as it might be, has a diameter of 1/2 inch. But what we actually have to do is we are going to have to put the pokey end right smack dab in the middle. And we're going to have to put the pencil lead at like the outside of the circle. And honestly, what we're going to be doing is we're going to ask ourselves, what is that distance? Well, it's the radius of the circle. But the radius of the circle is going to be half of this. What's half of a half? 1/4. So you're going to have to make sure that those tips are 1/4 of an inch. No, just a second. Our scale is 2 to 1. So we're actually doubling it. So it's a quarter times 2, so we're back to a half. So when you figure out how far your tips are apart, you have to make sure they're half an inch apart. Half an inch apart. Okay? So the tips of your compass need to be exactly half an inch apart. And that's the trick. You're going to have to measure them on the ruler and make sure they're exactly half an inch apart. And if they're a little bit less or a little bit more than that, then just spin the wheel so that they get to exactly half an inch apart. Now you may have to adjust it so there's less pencil or more pencil or less point or more point so that the two of them cooperate when they're on the paper together. And it could be a bit of a learning process, especially if you've never really used compasses like this before. But basically what you then want to do is you want to create that circle. Now, there's no real way that I can do this, unfortunately. So I just kind of have to fake it. But there's kind of my fake circle. Okay, and what you want to have to make sure is that okay, you got that circle drawn. That's good. Now we're gonna have to do that again. But this time when we do it, we have to look at what the distance between the tips needs to be for the bigger one. Now the bigger one, the diameter is 3/4 of an inch. Okay? Now, here's the thing though. What we found was, for the last one, we took half of it because we looked at the radius, and then we multiplied it by 2. If you take half of something, and then you multiply it by 2, you're not really changing it. Like, what's half of 10? It's 5. But if you double it, you get back to 10. So if you take half of a number and then double it, you get back to the same number. So for that reason, we are going to be making sure that the tips are now 3/4 of an inch apart. 3/4 of an inch apart. But you still have to make sure that the pointy part is going to go in the middle. The pointy part needs to go in the middle. And then we have to draw a 3/4 of an inch circle around it. And so what you're going to end up getting is you're going to end up getting something like this. You're going to end up getting a circle with another circle around it, and it's going to be a uniform circular width around it. Okay? And when you're done doing that, then you can label it appropriately, saying that this is half an inch and this is 3/4 of an inch. So we're using our orthographic views here, and we're using it on a washer, and we're able to come up with each of those things. And again, your drawings might look different than mine. Just remember that with my screen being able to zoom in, zoom out, all that kind of fun stuff. My stuff is going to look a little bit different than yours, but you should end up with 2 circles, and you should end up with a uniform width around the circles. And yeah, that's what you should end up with. So, all right, one final example. Each side of a Rubik's Cube is 57 millimeters long. Draw a 120% scale diagram of one of the smaller component cubes using isometric dot paper. So just for some clarification here, we're not doing the whole Rubik's Cube. We're just taking one individual cube. One individual cube. So here's the deal. Here's the deal. If this whole thing here is 57 millimeters, how much is one of these? If the whole thing is 57, how long is one of those? What do you think? It's going to be 57 divided by 3, which is 19. So it's going to be 19 millimeters. Okay? So, and because these are cubes, the length, the width, and the height are all 19. But what it's saying here is we're going to draw a 120% scale diagram. So that means in our scale diagram, our stuff is 120% the size. So when something's 120%, when you're finding out what 120% of something is, like anything, then you take whatever the something is and you multiply it by 120 over 100. So in this case, we want to know what 120% of 19 is, because that is the side length. So 120% of 19, that's going to be 19 times 120 over 100. And I think that's going to be 22.8 millimeters. Okay? So 120% of 19 is 22.8 millimeters. Now, using a standard ruler, it's next to impossible to measure 1/10 of a millimeter. So for our purposes only, we can probably bump this up to 23 millimeters. It's probably just best to do that. Because with a standard ruler, it's hard for us to measure in between those little notches for the millimeters. I know I can't do it. So there's no sense trying to do it. So what we want to do is we want to draw a single cube using isometric dot paper. Okay, no problem. So each of your sides needs to be 23 millimeters. All right. So I'm going to do it on here, and then I'm going to try and duplicate it over there. If I try and do that here, wow. 1, 2, 3, 4. Man, that's actually going to be, it's actually going to be 5 little grid squares. I'm actually kind of shocked at so much. So it's actually 5 grid squares for me. Let me see if I can just draw a line here. There we go. It's 5 grid squares for me. So that's 1, 2, well, it's 3, 4, 5. And I will make this just a touch longer. Now, we're going to go ahead and draw in the rest of the stuff. There we go. So the other sides would be 2, 3, 4, 5. No. Okay. 1, 2, 3, 4, 5, like this. One, two, three, four, five, like this. One, two, three, four, five, like this. One, two, three, four. Oopsies, I'm one short. That's okay. We can fudge that, I suppose. Go to here. Go to there. And go to there. Perfect. So there's our 120% view of one of those cubes from the Rubik's Cube. And again, I would go ahead and put the actual measurement down, and the actual measurement would be 19 millimeters. And you don't have to put it on every single side because it's a cube. And cubes have the same length, width, and height. That's why they are a cube.